Hello everyone, welcome back. This is Suresh here. In this session, we will look into the Google Cloud lab session. In this lab, we'll use the encoder and decoder. So without any delay, let me start the lab. And in this lab, we are not going to discuss or anything theoretical or technical. We are only going to complete the task provided for us. At any point, if you want to read the content, you can pause the video, read the content. But in this lab, this is the overview, and we are going to learn how to create a TF data set, encoder, decoder models in Keras, save as a model, merge the trainer encoder to translation function. So let me open the lab. Let me do the setup. So these are the tasks we are going to do. So till here we are good. So let's set up the environment. Let me navigate to APIs, library, search, select, open, and enable. Similarly, navigate to Vertex AI. So let's enable the Vertex AI. Either we can enable all recommended APIs. That should be fine. So let's create a bucket. So for that, go to the cloud storage, buckets. In the meantime, just go to the dashboard, the new tab. So just to copy the project ID or project name, whatever you want, because the bucket needs to be in the unique. Okay, create the bucket, get started. Bucket name is provided, continue. And this time select the region as US East 4. This is looking good. And continue, continue, confirm for the prompt. Public access will be prevented. Okay, create on this bucket. Okay, let's enforce this confirm. So during the bucket creation, let's go back to Vertex AI. Vertex AI, navigation menu, Vertex AI, workbench. User managed notebooks, create new. Let's US East. So let's give the name as lab workbench. Continue. And here by default, it is having enterprise 2.11, but I will select 2.14. The reason is I am facing some issues in the 2.11 while creating the environment or while creating or while executing this. So I will select 2.14 and continue. Maybe you can try it with 2.11 if possible, but I'm a little bit going with the 2.14 because previously this version worked very well for me. So rest and all, I will leave it as a default and click on create. So this is going to take about 5 minutes to get created. So once this is open, I'll come back. Okay, we have this Open Jupyter Lab. Let me click on it. It will open in a new tab. So task 2 is also completed. Let's go and clone the repository. So let me copy the code So let me open the terminal, paste it over. Either you can do what I did here, I just copied the Git code and then posted, or else you can create a copy cell and then you can see this. Copy to a new cell and then paste it over. Anything is fine by the way. So I'll wait for the few seconds for this to download everything. Once this is done, now task 3 also will get completed. So pending is task 4. So let me navigate to this training data analyst, sources, machine learning, deep dive, text classification, labs, RNN, encoder, decoder. So for the interest of time, I will open the solutions as well. Okay. So for the solutions, just go back to the text classification folder, solutions, and RNN, encoder, decoder. So you can also find the navigation path over here. So let me minimize this. We don't need this much of space from now on. This will take some time for us to execute. Let me go back to the lab. You can remember the lab file I have selected. I will go to edit and clear all outputs. Okay, you can pause the video and go through this learning objectives and the introduction. Without any delay, let me start with the cell commands. So shift enter that I used. So you may need to restart the kernel. Let me restart the kernel. Kernel restart is done. Now let me import this. You can see that Python 3 is kernel is busy. So we need to wait until the kernel will become idle. Yeah, this become idle, and you can then see this 2.14 version is the TensorFlow version. So this is the version when we created in the workbench, we created with this version. That is the reason it is showing 2.14. So model path and the data URL, Google API is download TensorFlow, Spanish English. I think that is the zip. Okay, let's see the random seed. Okay, we will use the language of dataset provided in many things. The dataset contains Spanish English. I borrow this book and this is the Spanish version. There is a curator. Okay. So let's copy this text and then put it in a translation record. Now let's read the CSV file and sample 3. You can see that is you can see the English and its translation as well. So let's see the sentence processing. You can pause the video and go through this and say the processed value. And integrized tokenized. Okay. Sequence text to integrized. Okay. So all this has been executed. And I want you to go through this speech, how this tokenizer works and what is this about. I want so you can go and understand here. Again, my intention is to execute the provided lab sessions in this code. Okay, now let's start with the exercise 1. This is for load and pre-process. So I have a one sentence pair needs to do. Without any delay, I'll go to solutions and copy the sentence pairs that is needed for me and paste it over here. Let's define the load and process. Looking good. English and Spanish. Loading the path sample files. Looking good. In exercise 2, okay, so input tensor, integer lang tokenizer. So let me go to the exercise 2, copy the 2 lines of code that is needed. Hit enter. Looking good. Now 80-20 split for the training and evaluation. Okay, all the input tensor, target tensor, input language, and target language. Everything is split. Now you can see the shape as required. So here the test prop, here we are using train test split and seed and all other details. The split is also perfect. Let's make the number example to split look like. Yeah, you can see the split tensor train is having 24,000, 24K, and the target is also having 24K. Input tensor has 24K, 6K, and target tensor has 6K. You can see the process as well. You can pause the video for the exercise 3 and go through the text what has been explained. So let me execute this code in the exercise 3. And shift enter. So create data set is also perfect. Actual train and data evaluation with the batch size of 64. Okay. So now we are creating a training data set and evaluation data set. So next we will start with the training the RNN encoder, decoder model. Here encoder input and encoder RNN in the exercise 4. So navigating to shift enter. Now you can see this is first one is embedding and second one is gated current unit. Similarly for the exercise 5, let me double check what I did here. Yes. And the as usual part, the decoder. Hit enter. So now we have the encoder inputs and encoder output, encoder state. Similarly for the decoder as well. Now dense, we are targeting vocabulary size as well as the activation model as softmax. Again, this is again you can pause the video and go through the content over here. Here we are targeting for sparse cyclic cross entropy. So let me copy the model. Enter. And you can see the model summary as well. Let's wait. So you can see the atom optimizer has been used and the loss of sparse categorically in cross entropy. I'm not sure this is ideal, but if this is still not, still it is in running state. So let me run the input tensor train. Uh, Let me try to quit. Still it is okay. Model is yet to be uh, available for us. So this needs to be defined. So let's wait for this step to complete. Okay, you can see the model is complete with the parameters. So now let's train the. Okay, so let's see. This is taking an ETA of about 5 minutes. How many epochs? Only one epoch. So I will leave. I will pause the video and we'll get back later. Okay, now you can see this. A model has been trained. So implementing the translation or decoding function. Again, I recommend you to pause the video and go through the whole content and the information that has been provided in this lab. Let's move on to the exercise 7. So create a Keras model here. Okay, let's do that for interest of time. Because when we try to do the typing or learning, the lab time will get ended soon. We will not have the time to type. Okay, so now let's. So definition is done. And in exercise 8, again, you can pause the video and understand what is exercise 8. So here we have a definition called decode sequences. So here, example, and the tokens as well. Now let's decode the sequence. So in errors. Now we are ready to predict. So sentences we have an array and reference translations we have in an array and decoding the sequence and printing out the range. So let's do this. So there is an input and reference fraction we are not eating. Machine learning, I don't know it. Winter is coming. It's not a bit. Okay. Now move on to the exercise 9. So let's do a checkpoint here. Something is missing over here. So nothing is missing. So let's this time we are saving the checkpoint or saving the load model. Now evaluation blue. So that is bilingual evaluation understudy. You can go through this. You can pause the video and understand. And let's do the blue one definition blue 4. Now in exercise 10, we will average it out. So blue one total and blue four total. We double check. Okay, good. Now let's print it. You can see it will take around 10 minutes, I guess, to my knowledge. Like blue one and blue four. And the training time is around 5 minutes. So let's wait for this to complete. And also, if you want, you can go to this GitHub for additional references if you need. Examples. That example is not okay. I will come back once this cell becomes available or ID, and I will let you know once this is complete or after 5 minutes. After 5 minutes, I'll come back. Okay, we still have 47 minutes. We'll try. Okay, coming back, you can see uh, it ran for about 13 minutes, and CPU user time is 13 minutes, and you know the rest. So blue one is 0.05 and blue four is 0.004. You can see performance of training of 5 minutes, but this is the below which they gave, but the actual performance is this. So this concludes our session. So have a great day. Bye. Close.